Hello everyone, in this video we'll be solving problem 27, remove element. The problem statement is given an integer array nums and an integer value, remove all occurrence of val in the array nums. Order of the elements may be changed. And then we need to return the number of elements in nums which are not equal to value. Looking at example number 1, the nums have the numbers 3, 2, 2, 3 and value is 3. After removing all 3's from the input nums, the output should be 2 and the state of the nums array should only have 2's in it. In example number 2, if we apply the same operation and remove all of the 2's, the output should only have 0, 1, 4 and 3. As we are applying in place operation, the size of the input nums array should not change. We are only removing all of the values that matches to the value 2 and all of the remaining positions can be filled with any values except for 2. Let's switch to whiteboard and discuss different approaches how we can solve it. One simple approach is to iterate through the input nums and save all of the unique values into a different collection. And after the iteration is done, if the size of the collection do not match to the input nums, we'll add the remaining entries to the new collection with values not equal to the given value in the input. And before adding the elements, we'll record the size of the new collection as that will be our output. With this solution, our time complexity is O of n and space complexity is O of n as well, where n is the number of elements in the input array. Because we are creating this new collection, the space complexity is higher. Let's brainstorm a solution that gives us a time complexity of constant space. Another way to solve this problem is using two pointers, where we'll use the first pointer to iterate through all of the elements in the array, and the second pointer will be pointing at the position whose value is equal to the value given to us in the input. Instead of creating a new collection with all values that are not equal to value 3, we'll use pointers to point to the position whose value is equal to 3 and replace it with a valid value. So basically whatever the number that first pointer is pointing at, it will take that value and save it to the position that second pointer is pointing. The first pointer will be incremented every time, but the second pointer will only be incremented if the value that I is pointing at is not equal to the value given to us in the input. The idea is that if second pointer is pointing at 3, we don't want to move forward unless we replace it with a valid value. Let's run a couple of simulations to understand how will this work. Let's set I as our first pointer, j as the second one, and the last column is the state of the starting with I is equal to 0 and j is equal to 0. Both are pointing at value 3. As the value is equal to 3, we'll only increment I and leave j as is. The reason, as we discussed, we want to replace all 3's with a valid value. As we did not do any copy, the state of the input nums will stay the same. Continuing with the next iteration where I is equal to 1 and j is equal to 0. As the value I is pointing is not equal to the value given to us in the input, we'll copy its corresponding value and save it in the position that j is pointing at, which means we'll save it at index 0. So after doing the copy, the state of the input array will be 222130. Please note that we are not doing anything to the position that I is pointing at. We are only copying the value at I and saving it at the jth position. As we iterated over a value which is not equal to the input value and copied it to jth position, we can be assured that there are no more values matching to value 3 in the nums array before I. So for the next run, my I will be 2 and j will be 1. I is pointing at 2 again. As it is not equal to the value, we'll do the same operation of copying it over to the jth position, increment both of the pointers and continue further. The new values are 3 and 2. I is pointing at 1. It's not equal to 3. So we'll repeat the same operation as before. After the copy, the input nums will be 221130. Continuing further where I is equal to 4 and j is equal to 3. Now I is pointing at 3. As the values is equal to 3, we don't need to copy and we'll continue forward by only incrementing the I pointer. Moving on with I is equal to 5 and j is equal to 3. I is pointing at 0. As it is not 3, we'll repeat the same operation of copying the value into the jth position and increment both pointers. As we are at the end of the nums array, we'll stop the iteration here and return the value saved in j, which is 4. And the updated nums array will have 221030. With this solution, our time complexity is O of n, as we are still iterating through all of the values in the given input array, and the space complexity is improved to O of 1, as we are using the very same collection and updating its value at different positions based on two-pointer approach. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here is the C# solution. I start by initializing my j pointer, setting it to 0, and then begin with a for loop for the first pointer, that is I, starting with I is equal to 0 until I is less than nums.length. If the value that I is pointing at not equal to the value given to us in the input, then I'm copying the value and saving it into the position that j is pointing at and then incrementing j pointer. If this condition is not satisfied, then we don't do the copy and move on. And once the iteration is done, we are returning the value saved in J. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime complexity and beats nearly 55% in terms of memory utilization. Thank you for watching this video. I hope you were able to understand this explanation and the source code. A link to the code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.